Okay, for everybody that's watching this, let's go ahead and jump into interior and exterior sums of polygons. We have some popular polygons here and their names and our number of sides here. We all know our triangle. Quadrilaterals is any four-sided shape, kite, or trapezoid, parallelogram. Pentagon, 5 sides. We have the hexagon, has 6. Our heptagon has 7. Octagon, 8. Nonagon, 9. We got 10. It jumps, 11. Dodecagon's 12. All right, so let's talk about interior sums here. We all, hopefully everybody watching this remembers the interior sum of a triangle is 180. Let's see if you remember the interior sum of any four-sided shapes, 360. Some of you might not know, but the pentagon is 540. Hexagon is 720. And the heptagon is 900. One more, our octagon, 1080. Okay, I want you to take a second to look at these. And a lot of people that are watching this might notice something here, that there is a pattern. What I mean by pattern is as it goes one more side, that means starts at 3, adds a side to 4, adds a side to 5, adds a side to 6. As the sides go up, a lot of people are already noticing that it has a consistency of going up 180. So here is our challenge, is that if I want to know the interior sum of something bigger than a 12-sided shape, maybe like a 30-sided shape, that's going to be kind of hard to continuously add 180. So for this section, we are going to use a formula. So in all of our formulas that we have here, n is always number of sides. And as you can see that as the number of sides go up, we are adding 180. So it's kind of 180 times n. But there's a problem. If we had a 3-sided object, we know the interior sum's 180, but if we put it in this little formula, 180 times n, it's going to be 540. It's not going to be 180. So this formula right here isn't complete. So how do we make this formula complete? To work for any polygon, as long as you know the number of sides, you have to subtract 2 first from the number of sides times it by 180, and you will get the interior sum of any shape, any sided polygon that I give you. The reason why we subtract 2 is because a polygon starts with 3 sides. You can't have a polygon that has 1 side or 2 sides, so you have to subtract those 2. So if I want a triangle, 3 sides, I put it in for n. 3 minus 2 is 1. 1 times 180. Bam, it works. All right, moving on. So that's the interior sum of a polygon, is to do n minus 2 times 180. We're going to use that daily in this section. Let's talk about exterior sums. Now, this is on the outside. So I have an equilateral triangle and 3 sides, 3 angles of 60. So here's how we can find all of our exterior angles. So all of these are going to have half circles of 120 out there. So all these exterior angles are 120. So there's 3 of them. 120 times 3 is 360. So the triangle has 180 degrees inside, and this one has 360 outside. Let's see if that pattern holds true here. Got a 30, 60, 90 right triangle. This one right here is another 120. So this one right here with a half circle here, this would be 150. And then we have a 90 here. So 180 inside and 120 plus 150 plus 90 again is 360. So you might see a pattern that the exterior sum is doubling our interior sum so far, but let's look at a rectangle. So a rectangle with all 90 degrees, that means it has all 90 degrees on the outside angles. So the four-sided shape has 360 inside and 90 plus 90 plus 90 plus 90 on the outside. The exterior sum is also 360. So our little pattern here for doubling the interior doesn't work. But what you need to know is that there is no pattern. Every single polygon has an exterior sum of 360. Every single one. So there's no special formula. It's just a number you got to remember. All right, so let's look at polygon versus regular polygon. All right, every time we have polygon, N is always stands for sides. Interior angles. Now, interior angles of a polygon can be different. The exterior angles can be different. But let's go to a regular polygon. Once again, N is always sides. Interior angles, because it's regular, means all sides and all interior angles are the same. And also, why am I saying same here? We don't know, but we'll fix it. All interior and exterior angles are equal and all sides are equal. So here's an example is just a triangle. This could be 110. This could be 30, 40. This is the regular triangle, which is the equilateral triangle. All interior angles are 60. All exterior angles are 120. All right, so here's what we need to work with, these formulas. So N is sides always. Interior sum is that formula we already talked about. It's 180 times N minus 2. And we already talked about there's no fancy formula for exterior sum. It's always 360. But when it says regular, there's an important word that we got to make sure we see. We got to see the word each interior and each exterior. So here's the formula for when we see the word each. So we start with N minus 2 times 180. And this formula, what we need to add to it is divided by N. And that will get us each interior. Okay, each exterior, it's pretty simple to remember. Remember, all polygons have an exterior sum of 360. If you want to get each, we just divide it by N. Now remember, these two formulas only work with regular. That's it. Okay, so here we have a regular octagon example. How can I find some stuff about this information? Remember, if it says regular, I can do the word each. Okay, so what can we find out about a regular octagon is the total was N minus 2 times 180. So that gives us the total. And if it's regular, we can find each interior. So we would take N minus 2 times 180 divided by N. So we would get every single one of these inside guys. And to get each exterior, we just divide it 360 by the number of sides. Also, I want you to see this, is that every single exterior-interior combo is a half circle. So every interior and exterior should have the 180. So, for example, if this is 160, that's an example. I'm not sure. I haven't done the math. Its exterior should be 20 because these have to add up to 180. All right, so here's an example of this a problem that's going to come up. Practice problems. If you want to know how to solve for x in any of these problems, this is a more sophisticated one. So what you do is you got count sides and find interior sum on every single problem we get like this, and we have to find x inside of a polygon. So we count the number of sides and find its interior sum. This is what we do every time. This is first. So this has 7 sides. I just 1, 2, 3, 4, 5, 6, 7. So this has 900. Okay, make an equation, account for every angle in the equation. So these are called reflex angles. That means they're bigger than 180. You're not going to see that very often, but I did make an object that it requires to have those angles right here. So if it has 7 sides, it has to have 7 angles. So I got 1, 2, 3, 4, 5. But then we have to account for these 2 reflex angles. So I just get 100, 110. These 2 make 4x plus the 2 90s down here plus those 2 70s equal 900. And it's basically solve an equation. 4x plus 830 equals 900. Solve for x, and you have your x. All right, so I hope this video helps work with interior, exterior polygon angles and shows you how to work with some of the formulas you will need to use.